I'm going to review that right now with you so that you kind of know what you're doing here. In case you weren't here Friday even, maybe this should help you out. Let's start with the first type of problem. The first one, this is, I think, problems 1 through 3. They give you something like this. That's what they give you. That's it. They give you two numbers, and if you read the instructions, it says find the geometric mean between them. Okay, so the goal is to find the geometric mean. Okay, if you don't know what a geometric mean is, it is basically when you have a right triangle and you drop an altitude straight down. This is the altitude going straight down from the right angle straight down to the other wall. This wall is the geometric mean. It's how tall the wall is. And so what they're giving you, the 3 and 18, these are these walls down here. That's what they're basically giving you. A lot of people always think that geometric mean is like an algebraic mean where it's like an average. We're not doing that. So how you actually set this up, this is how you do it. You take, you would not need to draw the picture, by the way. This is just to help you visualize what they're asking for. So they give you the two numbers, just like problems 1 through 3. You have to put those numbers here and here in no particular order. I don't care what order you put them in. Then you put x in the other diagonal spots, and that's the x you're going to try to solve for. So to solve this problem, you cross multiply, and you set them equal to each other. X times x is x squared, not 2x's, it's x squared. Then you multiply the other ones, 3 times 18. 3 times 18 is 54. And then you take the square root of it. Now this is the part where if you want to break down 54, that's fine, you break it up in all the things, you circle pairs, kick them out. Or you can type it in the calculator. I do want to see that answer though. Like the work I should be seeing on paper is this. But if you want to type it in your calculator just to see what the number roughly is, how you actually do this. So anyone have a calculator like that's with them? So I can kind of show you with your calculator. So okay, perfect. Oh, you guys have the same type. Perfect. Okay. So if you have one like this, how you actually type the square root key, you have to hit the little second key. And then the square root button's like right around this number 7, it's right here. So you hit second, you hit the little square key, it should appear on your screen. Then you can type in the 54 after it. And it should give you a weird decimal 7.3. Okay?
So do you want a decimal or not?
I need to see all that. If you want to see what the number is, you can type it in. I'm not requiring that you give me the decimal on this particular problem.
What about like the...
But again,
what about like breaking it down?
Okay. If you break it down, that's fine. That would be an acceptable answer. I do not need to see the decimal. So if you break it down, that's where you go. 54 is 2 times 3 times 3 times 3. Okay, that's 54. It's 6 times 9. And then you could break those down. And then you would circle a pair. So I have a pair of 3s, and you kick one out. So the only thing that will be left is the two numbers I didn't circle, which is 6. So that would be your final answer. I would accept that or this, not that stupid number. But if you want to type it in, because some people like want to know like what is the geometric mean? It's a digit, it's a number. It's how tall the triangle would have been if these were the numbers for the bases. That's what a geometric mean is. Questions, comments about the first one? What I expect to see on paper is probably this. I think it's super easy. You don't need to draw the picture. You don't want to break it down. You can just write this down and I'm totally fine with it. That's a geometric mean. But if you want to know what it is, that's the number. It's not an average. So just kind of keep that in mind. And how do I know like it's 7.3 made sense for that? Because again, these numbers are pretty small. Now these are single digit numbers. You know, this is a double digit, but they're not really big. They're not even above 20. So I would expect this to be kind of smaller as well. So that number makes sense, 7.3. And the other thing is the square root of 54, just like guesstimating in my head, the square root of 54 is just above the square root of 49. The square root of 49 is 7, because that's a perfect square number. The square root of 64 is 8. So it was a number between there. So 7.3 made sense. Why the calculator was giving me that. So that's how you can kind of guesstimate in your head. Questions with geometric mean and how you do it? Alright. Let's talk about 8.2 and 8.3. We got to do a couple of those. Is there any questions though with the first one? Like you're going to have, I think you have 3 of these, I think. They just give you the numbers, you have to find it. But again, I want that work. Questions?
Never mind. I was going to ask you to show your work.
I want that. Okay. Okay, let's go to the second one. Now the formulas are on the board. I'm going to leave that as you guys work today in case you need to look up and see what the formulas are. or you can use your notes, kind of required that I want your notes here today. Let's do one of the first ones where they want you to find the height of the triangle, the altitude. Or maybe they give the altitude and you need to find the parts of the base. So let's say this is a right triangle. And again, when you have your picture in your book, like you have the luxury of your book, you can like orient your book, you can like turn the book so that the picture looks like this. Where the hypotenuse, this is the hypotenuse wall, it's the base wall, is flat against you. It's like against your tummy, right? So it's flat against you, and then you can actually set up your formula. So the idea is that on this first one, this is theorem 8.2. 8.2 talks about the geometric mean. So theorem 8.2 talks about the geometric mean. And it basically, and I think I've put it in quotes, we had to use the altitude on this particular theorem. So if you look back at the notes, that's what I've kind of highlighted. So on this problem, I need the altitude. I need how tall this triangle is. This number, that's the altitude or height. So if you have that number, you can use that plus the two parts of the bottom. These are the parts of the hypotenuse. Okay. How I know that the parts, they're separated by that line. It broke the bottom into two parts. So I'll call that part 1 and part 2. Doesn't matter which one's which. But you're going to use those two parts and the altitude. 2 of the 3 numbers have to be provided for you. 2 out of the 3. I don't care which 2. Maybe they give you the altitude and a part 1. You can find the other one. So, for instance, maybe the altitude is, let's say the altitude is, I don't know, 12 feet. And let's say this part 1 is let's say it's 7 feet. We can find part 2. Because maybe that's the numbers that they have given you on your picture. So I can go find the other part of that hypotenuse. And once I have that part, I can figure out what the whole bottom is, because you can add these two together to figure out the whole bottom. But again, how you do this, what the formula is, and again, you can see it over there. When you set this up, you put your altitude here and here for that theorem 8.2. They want the altitude in the geometric mean spot. That's the diagonal area. So that's your altitude. That's the geometric mean. And then the parts of the hypotenuse would go here and here. So I don't care which one's part 1 and part 2. It really doesn't matter. You can flip-flop them. But that's how you set this up. So my altitude happens to be 12. So I can take the 12 and plug it into the 2 altitude locations. 12 feet and 12 feet. Part 1 and part 2. Part 1 was a 7 feet. And part 2 is the one number I don't have. And then you just solve. But you have to know how to set that up when you look at the picture. You got to see the numbers. Like when I look at this picture, my eyes are immediately drawn to the 3 numbers closest to each other. Like those are the 3 I look at right away. And I can use this formula. But again, you have to know where to plug them in. Now again, if this is your setup, you have to start with a number above or below x. That's what I told you on Friday. You cross, multiply, and divide, and it looks like a little goldfish. It's called the goldfish method, or prime, or cross product. That's the correct term. But again, you take 12 times 12, divide by 7. And that's 144, and divide by 7, which, what would that be? It'd be a 2, 0 point something. So, 2045454545. 144 divided by 7. Oh, 20.5. It's close. Okay, questions on how I found x? And again, now that I know this is 20.5, now I know the whole bottom is 27.5. That's the whole hypotenuse now. Okay, make sense? Now let's say we're missing the altitude though. So let's do another one. I'll just draw another triangle here just so you can see this. So now let's say on this one, same thing, you oriented your picture, so you turned your book so that the picture looks like this. So the altitude is coming straight towards you, your torso. Okay. Let's say we have these 2 numbers on the bottom. Let's say this is 10 and 15, and I don't know how tall the triangle is. So again, it's this exact same problem. The altitude is the one number I'm missing, so if you set up your formula correctly, that's the number I'm missing. That's my altitude, x and x. Because remember, the altitude always goes down the diagonal. Then the parts of the bottom are 10 and the 15. And let's say these are meters. Let's give them a label. Now, since that one has two variables, how do you solve it? Question. Oh, you know how to do it? How would you do it?
No, you can do that.
Okay.
My question's kind of irrelevant
Alright.
at this moment.
So when we multiply, right, cross multiply, you can't really start above or below something because we have two variables, we have two letters. So you just cross multiply. So x times x and 10 times 5, which is 150. And it's 10 times 15, not 10 times 5, but 10 times 15. And then to solve that, you take the square root. And that's the type of math I'd be looking for. Now, if you want to type that in your calculator, you can figure out what the square root of 15 or square root of 150 is. I would expect it to be a two-digit number, probably around 12 point something, just because the square root of 144 is 12, so it's just a little bit above that. Not quite 169, that'd be the square root of 15. Right, or square root of 169 would be 13, so it's 12 point something. But that's the height, and that's kind of the numbers I was expecting. These are two-digit numbers, kind of small. I expect that to be a two-digit number, kind of small. But again, if you want to leave it like that, that's fine. If you want to break it down and, circle numbers, kick them out. But that's how you do it. You're going to have, I think, quite a few problems here where you have to find the altitude. Like there are certain problems where they have multiple letters on a picture. So if you're finding the altitude, those are the numbers you have to use. Maybe they have a part you're trying to find, but they give you the altitude. So just whatever your picture is, usually I try this formula first, the altitude formula. That's kind of my go-to. Okay, questions, comments? Okay, we're going to do the leg formula now, and then I'll give you a bunch of time to work, about 20 minutes. Okay, so let's do the leg formula now. Same thing, almost the exact same picture, but now they're going to be using different parts of it. You can kind of see the formula over there. I have them written on the board for you, but I want to talk about it so you can see how to use it. Okay, so on this one, so here's how the picture is slightly different. It's still the same right triangle. Again, I would orient, Jesus, terrible right angle. So on this picture, I would definitely try to orient so that the peak of your triangle is up at the top, the hypotenuse is flat against you. Again, this is the hypotenuse, it's the longest side of your right triangle. That's how I know which one's the hypotenuse. So if you need to turn it so the hypotenuse is flat against you. We have the altitude still drawn, even though they don't even care about this in this particular formula, the second one, theorem 8.3. I don't care about the altitude, they don't even label it. They label pretty much everything else. So when they draw the altitude, they have the parts of the bottom. So this is part 1 and part 2 of the hypotenuse, right? Doesn't matter which one's which. I don't care which one's longer. It can be drawn out of scale. And then the other thing that they label now is the legs. So this is the leg, called leg 1 and leg 2 of your right triangle. So on this one now, we're using one of the legs, a part of the bottom, whatever part we're using, and then the full hypotenuse. So those are your three numbers you're going to use. So I'm going to give my example. I'll do an example over here. Let's say that I had let's say this is 12 meters. And I want to know how big the whole hypotenuse is on this particular drawing. So let's say that's my example. So they're definitely giving me a leg, so they're giving me leg 1 on that picture over there. That's the 12. They're giving me the 10, which is part 1, and I want to find the full hypotenuse. Because again, if you're looking at theorem 8.3, 8.3, it is still talking about the geometric mean again, still using that term, which means you're setting up a proportion of some sort, but now it's using a leg instead of the altitude. So when you set up your formula for this one, the formula for a geometric mean using a leg is it's two fractions that equal, that's a proportion. The leg would go here and here, whatever leg you chose. In our case, I'm using the 12. So that would go there and there. The part closest to your leg, again, I'll put closest here, and the full hypotenuse would go on the other spot. That's the formula we talked about Friday. The part closest to your leg, the full hypotenuse, and whatever leg you chose. So the numbers I have on this picture, I have the 10 and the 12. Well, the 12 is the leg. So that would go here and here. That's where you put the leg. The part closest to the leg is the 10, and the full hypotenuse is the one number I don't have. That's the number I'm trying to find. So again, 12 and 12, 10, so it's a 12. So 12 and 12 and 10, so you cross, multiply, and divide. So you take 12 times 12 divided by 10. If you do that correctly, you get like a 14.4. That'd be your hypotenuse. Would be the full bottom. And again, that would make sense. You know, these are kind of smaller numbers. So I'd expect a 2-digit number here. And now the beauty thing is, if you know the 14.4, you can now find this number over here. Because if that's 14.4, then that means this has to be 4.4 in length. Because these have to add together to make the full bottom, which we know is the 14, which is kind of nice. And then I can go after the altitude, because I can do the altitude formula, because I have these three numbers. Or I could go after the leg over here, because I have the leg, the part closest to the leg, and the full bottom, which is the 20, or the 14.4. So like you can kind of like, when you have a picture, you can go after all of them. You just have to know how to start it. All right, I'm gonna leave that on the board. You have the remaining part of class, which is 20 minutes, actually 22 minutes. It looks like we're not gonna probably start our new property today. We'll probably start tomorrow. As you guys are working, I'm gonna hand back some papers so you can make fixes. So if you haven't checked your JMC grade book, I'll probably send an email out this morning about it. Chapter 4 stuff has been entered. The only thing that's not in there is I think the previous assignment, the one that was due Friday, or last week, it was 278, 289. That was the one that was due last week. Make sure that gets turned in if you haven't already. If you see a lot of LIs, figure out what to do, turn it in. I'm gonna hand back papers, you can make fixes, do all your stuff, you guys know the drill. But I'm gonna hand back semester tests and stuff, so you can keep those, I don't need those anymore. So I'm gonna hand back quite a few things, but definitely check your JMC grade book. Some of you have not turned in anything for chapter 4 yet. It's kind of scary. So, all right. The rest of the time is yours. You can move around. You can do whatever you need to.